Good morning, sixth grade. Hopefully, everybody had a great night and you got through that catch up day and all your work is done. So, now we're moving on to chapter 11, lesson 7, dilation. So, let's see where we can figure out where that's at. So, in your Google Classroom, your pre algebra, go into your classwork, go down here to chapter 11. It's your top of chapter 11. Click on that and you will see your notes located right down here, chapter 11. Lesson 7. So let's see what we have right here. Okay, today we're going to look at dilations. Now, we've already talked about translations, reflections, and also our rotations. And the key thing with dealing with those three types of translations or types of movements of a shape, the size has always stayed the same as the shape. Now, what we're going to be dealing with here is a dilation. A dilation is now going to change the shape to some type of a scale factor. So let's see what we're talking about here. So it says a dilation is a transformation that enlarges or reduces a figure by a scale factor. So everything must be done on the same type of a scale factor. Either we're going to double the size. Now, if we're going to double, just to give you an FYI here, so if we're going to double the size of this corner piece, guess what we have to do with this piece up here? We have to double that also. We have to double this. We have to double this. So we're doubling that whole entire thing. So if we talk about enlarging, we know with enlarging, the object is going to get bigger. If we are dealing with reducing it, the object's going to get smaller. Okay, so that's going to be very important to understand. So it says, when the center of dilation is the origin, you can find the coordinates of the image by multiplying each coordinate of the figure by the scale factor. Okay, so that's what we're going to be doing here. That'll make our lives a lot easier. It says, use the notation x comma y. That means we're going to take whatever that scale factor is, which we're going to call k. K times x, comma, k times y. And then in order to describe what our dilation is going to be. So let's look at an example with this, just so you understand what's happening here. Okay, it says, a figure has the vertices, j is 2, 4, k is 2, 6, m is 8, 6, and n is 8, 2. Graph the figure. So let's go over here. Let's do that here first. So as you can see, we graphed this figure right here. Okay. Here's all of our points. We connected everything. And here I have my JKMN. Okay. There's my figure there. Now it says the image of the polygon after dilation with a scale factor of 1/2. Now, it's a scale factor of 1/2, which means it's less than 1. If it's less than 1, that means it's going to be smaller. So think about it like this. If you have a scale factor that's less than 1, the new object will always be smaller. If you have a scale factor of greater than 1, the new object will be larger. Now, here's a trick question. Maybe not that trick. Hopefully you know it. What happens if the scale factor is just 1? Do you know the answer? The object is going to stay the same. So make sure it will just stay the same. It will be exactly over top of it. So let's take a look here. So all we did, we know that our scale factor is 1/2. We know that our object is going to be smaller. So we're going to take our first our coordinate, our vertice, j. J is 2, 4. So what we need to figure out, what is j prime going to be? All I do is I take my x. My x is 2. I multiply it times 1/2. So my new coordinate for my x, for my x for j prime is 1. Take my y. 4 times 1/2 is going to be 2. So my j prime new coordinate is going to be 1, 2. And you can see where we marked it right there. Okay, go with k. Take your x, multiply it by 1/2. That gives you 1. Take your y, multiply by 1/2, gives you 3. That means k prime right here is located at 1, 3. Do the same thing for your m. 8 times 1/2 is 4. 6 times 1/2 is 3. That means m prime right over here is going to be located at 4, 3. Plot that. n, 8, 2. 8 times 1/2 is 4. 2 times 1/2 is 1. 4, 1/2 is, I'm sorry, 4 comma 1 is our n prime located here. Connect your points, and then we have just reduced it. Very good. Very, very good. Okay, let's scroll down here now. It says a figure has vertices. D is that. E, F, G. Plot the points first. So as you see what we did here, we made sure that we plotted our points. Here's D, E, F, G. Connect all those points. Now it says the image of the polygon after the dilation of a scale factor of 1/4. It is less than 1. So is the object going to be larger or smaller? Smaller. Very good, because it is less than 1. Okay, very good. So we take our D, which is negative 4 comma 4. We multiply each of those by 1/4, which D prime becomes negative 1 comma 1. So negative 1 comma 1, right there is our new point. E, 4 comma 8. Multiply the X and the Y by 1/4, which gives us E prime is 1 comma 2. And here is E prime right there. F, 8 comma 8. Multiply those each by 1/4, gives you 2 comma 2. So F prime is going to be at 2 comma 2. And finally, G is 4, 0. Multiply each of those by 4 times 1/4. And G prime gives you 1, 0. And plot that, connect your points, and there is your dilation. Very good, guys. Hopefully, it's pretty easy for you today. Okay. It says a triangle with vertices A, B, and C. Find the coordinates of the triangle with a dilation of a scale factor of 2. Okay, that is greater than 1. 2 is definitely larger than 1, so our new image is going to be larger. So we just do the exact same thing. I have, first of all, mark your A, B, and C. Here's A, here's B, here's C. Connect your points, and that is your image. Now our new image. We're going to multiply X and a Y by 2. So A, we'll multiply 1 and negative 2 by 2, which gives you 2 comma negative 4. Plot it here at A. Here is your 2, negative 4. Plot your point. For B, B is 0 comma 2. Multiply your X and your Y by 2. So that gives you B prime at 0, 4 right here. I'm sorry, 0, 4? Yes, 0, 4 right here. My bad. Okay, 0, 4 right up there. And then you have your C. Your C is negative 2 comma negative 1. Multiply each of those by 2. That gives you negative 4, negative 2. And that point is right here. Connect your dots there. And that gives your new image of a dilation of a scale factor of 2. Okay, let's continue on down here. Moving right along. Okay, it says right here, a triangle has vertices H, I, and J. So what you're going to do, you're going to mark these points. Here's your H. Here's your I, and here's your J. So they says so mark those, draw your lines, get your coordinates, find the coordinates of the triangle after dilation of a scale factor of 4. 4 is greater than 1. Since it's greater than 1, it's going to be larger. So take each of these coordinates, multiply it times 4, and gets us our new coordinates for our new triangle. So H is negative 1 comma negative 2. Multiply each of those numbers by 4. So when I multiply those by 4, H prime becomes negative 4, negative 8. So H prime is right down here. Let's go over here to I. I is 1 comma 4. Multiply both those by 4. You get I prime is 4 comma 16. Oh man, that's way up here. Way up here. We had to extend everything up here. So that gives us our approximate up there. And then finally J. J is 2 comma 1. Multiply each of those coordinates by 4, which gives you J prime is 8 comma 4. The J would be right here at 8 comma 4. Plot those in there and then connect those vertices, and that gives you your dilated shape, which is much larger than your original triangle. So let's look here, make sure we understand these rules when finding the scale factor. As you know, an enlargement, K is our scale factor. K has to be greater than 1 when it is an enlargement. When it's a reduction, that means it has to be less than 1, but it has to be greater than 0. We cannot have any negatives here. So it has to be less than 1, but greater than 0. And as we had said before, if we have a scale factor of 1, it is just the regular shape. Okay, so it says, if a figure has been enlarged, its scale factor is greater than 1. We know that. If a figure has been reduced, its scale factor is between 0 and 1. Just talked about that. When the scale factor is 1, the size and shape of the image does not change. It's in the same location too. To determine the exact scale factor, use a ratio. Okay, so that's what we're going to be looking at here. So it says the sides of the image of a figure being dilated are proportional to the corresponding sides of the original figure. Okay. To determine the scale factor, write the ratio comparing a side length of an image to the corresponding side length of the original figure. So let's see what we have here. So it says a drawing of a school mascot is to be enlarged as shown at the right. Okay, so here's our original. We're going to enlarge it to this piece here. Okay, so it can be painted on the gymnasium doors. Okay, what is the scale factor of the dilation? Okay, so let's take a look at this here. If we take a look at this here, what we're going to do, we're going to say, what is the scale factor of the dilation? Okay, what we're going to do new over the original. Okay, new over the original. Okay, this is the larger one. This is our new one. Over here, this is our original one. This is the small one. Okay, let's take a look and see what we did here. It says 9 minus 3 over 3 minus 1. Where did those numbers come from? Okay, well, let's take our x's here. Okay, let's take our x's. Let's see what we did with our x coordinates here. So I took my 9 minus 3. I'm sorry, back over. Yeah, this is my new. So 9 minus 3. 9 minus 3 is 6. Okay, 6 over my original 3 minus 1. 3 minus 1 is 2. 3 minus 1 is 2. I'm not sure why I put a 3 there. Change that and do a 2 right there. So 6 over 2. And 6 divided by 2 is 3. You can see how that works. Now, there's several other ways to look at this, okay? This is not only the only way to do it. There's other ways to do it too. Let's take our x value here, which is 3, over our original x value, which is 1. 3 over 1 is what? Yeah, you got it. That's 3. Okay, let's try the y. Okay, take our new here, which is 6, over this our original here, which is 2. 6 over 2 is what? 3. That works also. Go over here. Take this piece here. 9, my new, divided my original, which is 3. 9 divided by 3 is 3. That works also. And also over here, my y. 6 over 2, which is 3 also. So there you go. There's a lot of different ways to work on this. There's a lot of different ways to figure out, hey, what is the scale factor? So guys, that is it for today. Hopefully you understood everything. If not, go back through, rewatch the video. If you're still confused, send me an email and I'll help you out on things. Other than that, guys, that's it. Get started on your homework. I'm also going to attach into the email that I sent you some coordinate planes for you guys to print out and use, which may make your life a little bit easier. But other than that, guys, have a great day, and I'll talk to you guys tomorrow. Bye-bye.